All right, welcome to the second video of 3.3 hydrocarbons. Now, introduction to organic chem was done. In this video, we'll be looking at the third box down there. The chemical reaction of hydrocarbons are determined by the functional group present. Chemical reaction we are talking about now. Predict the product of an addition reaction of alkene. Now, before we move on, I think it's a good idea for us to look at what it means to be, what it means by, well, functional group. I'll also look at homologous group. I'll introduce alkanes and alkenes here. All right, firstly, what it means by functional group. Okay, it's an atom or group of atoms responsible for typical chemical reaction of a chemical. Now, this is a definition, so you better write that down. They determine the pattern of reactivity, chemical properties of a homologous series. Now, there's another word that you might not be familiar, so write that down. And there is an explanation of what homologous series mean. There's also a link that you can see here that leads you to learn. That leads you to the Quizlet flashcard that where you can learn prefixes. So 1 to 10, I think, 1 to 8 maybe, that you need to be able to remember, as well as functional groups. All right, back to homologous series. Important word there. A group of molecules with the same functional group, but a different number of CH2 groups. The length of carbon chain determines physical properties such as melting point or boiling point. Now, the last idea should not be new. If you increase the number of carbon chain or length of carbon chain, mass number becomes bigger, number of electron increases, therefore you'd expect boiling point, melting point to go higher. Now, the homologous series is like family. So someone with, I don't know, someone with glasses, they could be family, but they could come in different weight, different mass or size. But they're all wearing glasses, and glasses wearing people could be a bit different, special. Anyway, the hydrocarbons, they can be considered as aromatic hydrocarbons. It needs to have benzene-like structure. So 6 carbons connected in a ring structure with double bond in every second carbon. We're not going to really talk about that because what you have to focus on this year is aliphatic, non-aromatic ones. They don't contain benzene. Now, the homologous series that we were talking about just then could be saturated. And if it's saturated, we call that alkanes. Then the word saturated will be important, and also unsaturated. There are 2 types of unsaturated hydrocarbons. They could be called as alkene with E in it, or alkynes with Y in it. Alkynes, alkenes. These 3 are different, fall under different homologous series, or they are different homologous series. And now you can see the diagram just above there. Alkanes have no double bond. It's single bond only. Therefore, it's saturated. Okay, single bonds only means saturated. Alkenes and alkynes, on the other hand, it's got double bonds or triple bond. Now, they are not saturated. They are unsaturated hydrocarbons. Why? Well, they are not saturated with hydrogen. Okay. So alkenes with E, alkynes with AI, Y sound, they are not saturated. Oops, number 3 came up first. Each homologous series can tell you different things. The first thing is can be represented by a general formula. Now, from the first video, you might remember that I was trying to work out how many hydrogen would be in ethane. You can figure that out if you know the general formula or you know how to work it out. Secondly, adding 1 carbon on a carbon chain as CH2, because if you have got like 2 carbons there, and if you add another carbon in the middle, it would have 2 hydrogen that can attach to. So CH2 is what would be added. to each group every time you increase the number of carbon. Thirdly, chain length define the physical property change. Again, it shouldn't be anything new. It just changes the dispersion force. So melting point, boiling point would be increased. Solubility to water would also decreases. Now, I'm not sure if I added anywhere or not, but the cutoff line is 6 or more would be considered as nonpolar, regardless of what functional group is there. So 6 or more carbon would not dissolve into water at all. Okay. So anything that has more than 6 carbons in one chain, yeah, just think that they don't dissolve into water, unless there are a lot more of hydroxyl group attached to, like sugar. The chemical properties are usually similar. So ethane, propane, methane, they're all gases, they all burn, they burn cleanly. That's a chemical property. As an example, yeah. So alkanes, they only have single bonds. The general formula, I just say it here, is C with N, H, 2N, and then plus 2. So you will always have double the amount of carbon plus 2 extra if it's alkane, hydrocarbon with only single bond. They are all saturated compounds because they contain maximum amount of hydrogen atoms. C3H8 conforms the general formula, doesn't it? That's propane, C3H8, twice the amount of carbon plus 2. Structural formula, well, you can try drawing that now. 3 carbons, connect them together with H's around. Okay. Alkenes. Now, alkenes are something that has double bond. Okay. If you have two double bonds within the molecule, you call that diene. Diene. That's what you see in this meme here. General formula would be twice the amount of hydrogen. If there's only one double bond, the formula should be CnH2n. Hydrogen would be always double. Alkenes are said to be unsaturated because it can have 2 more hydrogens if it needs to. For example, like propene, this time C3H6, so it conforms the general formula too. You can draw the structural formula. Now, because of the double bond, and one of the bonds can break and grab onto some things, it can do what's called addition reaction. Now, alkenes can undergo, well, let's say that they are more reactive because of the double bond, and one of the bonds can break. So due to the presence of double bond is what you should put down up there. Alkenes can undergo addition. What does it look like? There's a general formula, but it's kind of hidden. I thought I had a white background. Oh well, there we go. That's white background one. Addition of small molecules, such as AB, that can be attached to, so if there were double bonds, one of them can break and grab onto something else. That's really what it is. Now, AB could differ depending on what you add. First thing that you could do is halogen. You could add Br2, Cl2, F2, and then they can just attach to there. Reaction with HCl, H would be coming attached to this side, and Cl could be attached to there. H2O, hydration can be done if you use high temperature and steam. H could be attaching to one side, OH could be attaching to one side. Eventually you actually make ethanol or methanol, or it shouldn't be methanol, ethanol or propanol or something with OL at the end, so it's an alcohol. Fourthly, reaction with hydrogen. So you are saturating it. You could saturate double bonds with extra 2 hydrogen atoms. That's a technique used to make olive oil, which is unsaturated fat, into saturated fat, margarine. you could also use same method of addition to make polymers. Now you may have already researched that and found out that addition reaction can happen to anything with double bonds. So double bonds can break, and then that can connect to another double bond, what used to be double bond. That's what it looks like. Now I would like you to try doing this. I would like you to try doing some addition reaction with propene C3H6. So what you have to use is this formula. Use this, well, the diagram is showing ethene. You have to use a propene here, okay? 3 carbons. With, in the position of AB, you replace that with chlorine, steam, hydrochloric fluoric acid, hydrogen gas, as well as 2 more propenes, or 3 propenes reacting together to form polymer. Try drawing them. All right, I'll stop there. We'll talk about alkyne later. All right, see you in the next video.